As more people joining us, let's wait 1 more minute. Hey everyone, this is Charlie Guo, the co-founder and the principal of XCAM. We're here to happy to host 2024-25 season USACO bronze test for the December ones. So we will have Alex Du, who is a USACO Platinum Division contest, will share his solutions of this contest. Alex Du is one of our students in the first class of XCamp since 7 years ago. He was the first one in XCamp history to pass gold with a 1,000 perfect score. He's now studying in Berkeley in computer science. Here, let's welcome Alex.
Hello, everyone. Yeah, I guess I'll just get started right away with the problem explanations. I hope everyone can see my whiteboard. And let me pull up the problem statement for the first problem. Yeah. So, well, first of all, I hope everyone has already read this problem. I'm assuming that if you are here, you've tried to take this contest. So I won't go over the problem statement too in depth, but basically we just have this problem where they give like a pretty complicated explanation on like, how to round or whatever, but in reality, it's just rounding to like the nearest number, right? Like everyone has done this before in school. So if you round to like the nearest tenth, if it's like 5 or above, you round up. If the ones are just like 5 or less than 5, then you round down, right? And the problem is asking for to count the number of numbers where if you round up every digit, so like 1 digit, 10 digit, 100 digit, all the way up to the largest digit of the number, you'll get a different number than if you just directly round the top digit. So the first thing to do when we see a problem of this type is to try out examples. And when we try out examples, we want to try out small examples and see if we can find the pattern. So if we first try out numbers that are just ones, just have 1 digit, so numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We see that it doesn't matter. Whatever rounding every digit before, so doing the chain rounding is the exact same as just rounding the highest digit, right? So like every number 5 and above rounds up, every number 4 and below rounds down. There's no difference. So here it would just be 0 for our answer. But now let's think about if the number has 2 digits. So if the number is in between 1 and if the number is in between 10 and 100, what are the numbers that can potentially have a different number rounding up and down? So then we have to think. So the numbers that would normally round down would be in like the 40s, right? So we think like any numbers that's in the 30s, even if we round up the tens digit, the ones digit, at most we're gonna get a 4 in the tens digit, and that'll still round down. So we don't have to consider anything below 40, right? But if we consider numbers in the 40s, if we have a 4 in the tens digit, the ones digit, so anything in the 40s is normally supposed to round down if we round directly. But if we do chain rounding, there's a way to round this 40 to a 50. So if we have like 45, 46, 47, 48, 49. These numbers we see that are supposed to round down to 0, but if you round them up, if you do chain rounding, the 1 digit first rounds up, it'll become 50, and the 50 rounds up to 100. So we see here that the numbers that we're going to get from 10 to 100, there's 5 numbers, which are the 5 I listed here that we can list. So that's the answer for these for number less than 100. So let's continue trying out even more examples. If we next try out numbers have with 3 digits, right? So I'll just take like 100. So obviously so the thing is for numbers like 100 and in the 100 digits there's going to be like 100 still gonna like any number that's like 100, 200, 300, 400, like 300 is still going to round to down to like 0 instead of next 1000, obviously. So the only numbers that can actually matter again are going to be numbers that start with 400 and then have 2 missing numbers. And the numbers here that we can have, like, so we need this number to round up to 500 while chain rounding. And we know that this number is going to round down to 0 while not chain rounding. So in order for this number to round up to 100, to 500 while chain rounding, this has to be, well, first it can originally be the 5 numbers we listed that will round up to 50. So from the previous case, so 44, 45, 46, 47, 48. But then also any number greater than that, right? So also like 50, 60, any number greater than 444 is going to chain round up to 500. And from there, we are starting to see a pattern, right? So for tens digits, for any number less than 100, for any number with 2 digits, we saw that the numbers that are going to chain round up are going to be any number greater than 44. And for the numbers that are in the hundreds, it's any number greater than 444, but also less than 500. Less than for this number, less than 50, and for here, less than 500. Because any number greater than 500 is supposed to round up, meaning that it's not going to be any different. So here, we have already found a pattern here, right? So for the pattern here is that so here there's going to be 5 numbers. For the second one, it's 55 numbers, right? If we count them. And then here it's the next one will obviously, like, if we continue the pattern, it'll be 555 numbers, right? Because it'll be greater than 4444 and then less than 5,000, so on. The thing is, once we find this pattern, we can solve this problem if n is any number that's going to be like a whole number, right? So if n is like any number with just like a bunch of zeros, we basically already solved the problem. The issue is now if 1 is like in between some numbers. For example, let's look at case 3, which is 4, 5, 6, 7, n equals 4, 5, 6, 7. How do we find the numbers here? So obviously we can first count all the 2-digit numbers, which is just 5, count all the 3-digit numbers, which is 55. But now n is in itself a 4-digit number, meaning that it could it's going to potentially encompass some 4-digit numbers, some of this 5555, but not all of it. But we know that the only numbers satisfying this condition of like rounding differently, chain rounding versus non-chain rounding, are the numbers that are greater than 4,444 and less than 5,000. So from here, we can just do some casework on basically the number of digits that n has. So if n's a 4-digit number, then we check if it's between if it's between 400, like 4,444 and 5,000, we just do n minus 4444. If n is greater than 4444 and less than 5,000. If n is greater than 5,000, then we can obviously, every single 4-digit number is included. So n is going to be like, it's just add 555 because we know that that's all the numbers in between out of the 4-digit numbers. And if n is less than 44444, then we don't need to do anything at all. Then like, because it's +0 because it doesn't include any 4-digit number out of there. And to actually code this problem, there's different ways. We could there's one way where we can, for example, just compare to n to 44, then 444, then 4444, and like so on, while also comparing with these numbers. So basically just looping up, increasing like the number of 4s here by 1, increasing the number of zeros in the 5 500 from 5,000, increase the number of zeros there every time, and just keep computing these three operations, right? And if we ever get to either of these cases, we just stop. Otherwise, we can keep adding. Does anyone have any questions about this problem? Uh, okay, I'm going to assume that's a no because no one said anything. Yeah. Okay, so we see that this problem is kind of like an example of it's mostly an ad hoc problem. It doesn't really use any one specific algorithm. It's more just you have to try the examples in order to find this pattern. And if you can find this pattern, the problem becomes pretty simple. You just have to have the ability to code the math required. But there's only let's see, someone wrote my is O of n solution needed? Um, this solution is actually not O of n. This solution is actually O of like log n pretty much. We see here like there's only gonna be 9 computations needed. O of n is not going to pass actually, because like O of n is where n is 10 to the ninth. Yeah, n is less than 10 to the ninth is not a valid solution. 10 to the ninth usually does not pass. So we see here that like we are not allowed to just loop through all the numbers and just try to round each one of them. We have to instead find this pattern of finding numbers. Yeah. And there's only going to be at most 9 computations because like the numbers we're comparing can only go up to 9 digits. And we're comparing once for each digit, basically, or like 3 times for each digit, but it's still like a very small constant number. Are there any other questions? Okay. So yeah. So basically like the main takeaway from this problem I think is to just try to make sure you fully understand the problem and to try examples. So a lot of times problems like this can be like generalized into um big chunks instead of having to manually, for example, loop from every number from 4444 to 5,000 to find like, oh, every number in between these is actually going to be rounded down. We can instead just represent this as a equation. So just checking if it's in between these. Okay, I'll now move on to the next problem. First, let me go clear the board. Is there a way to clear the board? I think I'll just close the whiteboard and reshare my whiteboard. Just share a new whiteboard. Okay. So now on to question 2. Let me go copy this image. Yeah. Hopefully everyone can see this problem. So we see here that we have this block of cheese with n by n, which is n by n by n with n from 2 to 1,000. So this block of cheese is going to have 10 to the 9 numbers. And there's going to be a sequence of a series of q where q is less than 2 times 10 to the 5. So let's list out everything. N less than 1,000, q less than equal to 2 times 10 to the 5th. And each query is an update from where you're basically removing a block from you're removing a block from this initial cube, and every single time after you query, you want to basically find how many empty segments are there of like m by m by 1, such that like every single block in the original cube is empty. So we see, it's kind of hard to draw from the original sample, but yeah, like the problem solution kind of has like an explanation. So after the first 3 updates, we see that there's 3 blocks missing, and we can draw like one vertical column down, and there's only one option for this, right? So the first thing we have to keep note of is that it's not going to be possible at all to simulate the original cube because n cubed is equal to 10 to the ninth. 10 to the ninth does not pass anything. So like we can't even make, like, for example, a 10 to the ninth array. So that means that simulating the cube is completely out of the question. So that means that we need to find a better way to like not directly simulate it, but find some other way to represent the problem where we can actually solve this. Right. So let's first draw out like kind of a 3D cube. So it's kind of hard to draw. Let me try to draw by drawing 3D. So we have this 3D diagram, and then let's draw the cube in this quadrant, right? It's a little challenging, but this should be solid lines like this. Okay, so we have this like kind of cube looking thing. The drawing skills are not quite there, but you guys kind of get the idea. We see that basically there's only 3 orientations for a 1 by 1 by n block to fit in, right? A 1 by 1 by n block is basically a block that's like like we can think of it as like a column, right? That's like 1 cube wide at the bottom and then like n long in certain direction. And I think the best way to think about this is like basically when we reorient it, like this is like if we think of this as like a 1 by 1 by n, we can also be like we orient it like this can be like a vertical cube, right? A vertical section of the cube, like one corner of it of our original cube. But the other 2 orientations is going to be basically like for example sideways like this, right? Where it's like 1 block tall and it's like kind of like on here. The drawing skills are kind of hard. And the other orientation is going to be, like, for example, this orientation. And the best way to pin it down is to actually think of it as like along which axis is it pointing, right? So if I label the axes here, so if this is like this one's x, so like this is the x-axis, this is the y-axis, this is the z-axis, right? We have cubes, so we can have a cube pointing in the direction of the we can have a 1 by 1 by n in the direction of the x-axis, like this. We can have it in the direction of the z-axis vertically, like this, or we can have the direction of the y-axis, like this. And there's only 3 possible orientations. And the other thing to note is that if we put, like, for example, if we decide to put a block in the direction of the y-axis, right? That means that along this entire block, y is fixed. No, not y. X and z and x are fixed, and only y changes, right? So for a block in the y direction would be like, for example, 1, y, like 2 or something like that, right? And y will go from 0 to n. Y from 0 to n minus 1. And similarly, a block in the x direction is going to be like x, and then with this y and z fixed. What is the production cutoff? I'll go over all the like contest summary stuff at the end. For now, I'm just gonna go over all 3 problems. So like a block in the x direction, right? If it looks like so the direction of the x-axis will be this way, right? Like going between these 2 directions. It'll have x fixed and then like 2 numbers for y and z. For example, like 2, 2. Right. And then similarly for z, it'll be like, for example, let's say like 3, 1, z, or z from 0 to n minus 1. So we see that like for any block, there's actually only 2 free dimensions. And with 2 free dimensions, that means that each block can actually be represented as a index in an array, which counts how many blocks are still left in it. So if we can kind of imagine it as if we have like we basically turn this cube into sort of like a square looking thing, right? Like we can imagine let's just only look at, for example, like the XY axis, right? So if we look at the cube only on an XY axis, we have X and Y here. So XY, Z will be Z will be like into the paper, but you can't see it. But instead we segment this block into an n by n. So like if n is 4, it's a 4 by 4 square with Z pointing into the page. And every single one of these initially has n blocks in the Z. Like every single, like we think of these, every single square in this grid, less of a square and more as like a pillar with n blocks currently in the pillar. And every single time we remove a block with a query, we're basically removing a one single block from one of these pillars, right? So this will turn, like if we remove a block here with like coordinates x, y, with the coordinates like, let's say, so this is 0, 0. This is n minus 1, n minus 1. If we remove this block, this is removing like 1 by 1 by any z. Any square with 1 by 1 by any z is going to be in this column. Can anyone understand? I hope everyone can understand that. So if we look at it like that, that means that when a column becomes 0, that means that it's another potential place to put this n by 1 brick when we answer the query. But if the column is not 0, that means that we cannot put a 1 by n brick there. And this makes the problem a lot easier. So now instead of having to simulate the whole array, all we have to do is simulate the 3 planes. So we have the XY plane that I've already drawn, and then we have a similar like symmetrical YZ plane where like looking into the page is the X direction. And every single one of these also starts off with a column as n by n by n. And every block here, like for example, like this block represents any cell that's going to be of the form of like X with any X and then 1, 1. 1, 1 for Y and Z, right? And then similarly, we have a like an XZ plane as well, like XZ. And then similarly here, this block would represent 1, Y, 1. And that means that every single time we make an update, we only have to update these 3 planes and then see if any of these, see if the column that they're in turns to 0 on anything. So for example, if we have a block, let's say, let me erase these things, right? Let's say we update a new, let's say we get a new block as a query. That's like 2, 4, 2, 4, 3 is not 1, 2, 1, 3, 2, right? So on the XY plane, right? We only look at the X and Y coordinates. Z is free. So on the XY plane, this 1, 3 corresponds to this block, right? So we can subtract 1 from this block. On the YZ plane, this the X is basically free. We only look at the Y and Z. So this corresponds to 3, 2 on YZ, which corresponds to this block. And on the XZ plane, 1, 3, on the XZ plane, it corresponds to 1, 2, which is right here. So this coordinate actually just corresponds to three separate points on these 3 planes, and we subtract 1 from each of them, and we see that any of them becomes 0. Then that's a new option to put a column there, right? And then we add 1 to the answer, and we continue doing this for every single point. Does this question kind of make sense to everyone? I know it's like a little hard to wrap your head around, but I hope like, yeah, like, so if you have any questions, yeah, please ask because. What's the time complexity? So the time complexity of this solution would be, so every single grid of this size is n by n. So it's 3 grids of size. So n by n is n 1000 squared is 1 million. And each time we only have to query 1 single point on these 3 grids. So the total time complexity is just going to be just so the time complexity for each query is O of 1, right? Is like because it's a constant time. It's only 3 operations. So the time complexity is first like n squared to make the arrays, to maintain all the arrays and set them all as n, and then O of q for every single query, because it's O of 1 for every query. So the time complexity is O of n squared plus q. And this passes because this is basically 1 million max, because q is 200,000. Does anyone have any questions about this? No, not really. Okay, so I guess like just kind of on this problem itself, like I think this was the problem that was probably the hardest on this contest. Like like once you have the observation, the code for it is actually really, really short. But the initial observation kind of like you kind of have to be able to like imagine like the 3D grid. right? And we think about like so every single point, basically every single 1 by n in whichever orientation is basically saying we fix two of the coordinates, and then the last coordinate is going to go from 0 to n, or like 0 to n minus 1. And so this leads to like kind of like the a logical observation that we basically don't need like we and the problem also like guarantees that whichever block it is the block that Farmer John removes, there's always going to be a block there. He's never going to try to remove an empty space. And that means that we don't actually have to simulate every block. We only have to simulate every column, since we know that every single time we subtract from the column, it's going to be like a valid subtraction, right? Like we wouldn't be able to do this if we didn't have the guarantee um that there exists a block that's space to remove. Because like right now we aren't even really checking if the block actually exists or not. We're not simulating anything. We're just saying that okay, it does have to exist. That means that we can, for example, for 132, right? We can if when we remove 132, we're basically saying we're removing one from the 1 3 square in the XY plane. Like we don't care like we know we and the arrays we have are storing like currently how many points exist in this column already. And if we're currently at 1 and we go to 0, that means that this column is now completely empty. So it's because of this that we're able to, yeah, like just make this observation and turn this problem from a 3D problem into basically a 2D problem. Okay, I'll give like 1 more minute for any questions. And if no one has any questions, I'm going to just go directly on to question 3. Or not like a minute, like maybe like 15 more seconds. Okay, I'm assuming no one really has anything. So I guess I'll just uh yeah, I'll close this drawing and open the next one. Okay, so next problem. This one took a bit more space. So I'll copy these 2 images in. The first half. This is the second half. Okay. So we see that let's go over the problem statement really quickly again. So the problem statement here says that we have basically n characters of n lowercase characters. So the first thing to do first, like list out all the variables. So n is less than 20,000, right? And a mu is defined as a substring of like basically a, b, b, where like a and b are different characters. And basically moves a lot. So yeah, so like basically we have to look for any like the number of strings. Like we have to look for the number of potential ABBs whereby like where we're allowed to do one change on the original array and we want to have at least 5 ABBs. Okay. So we have here that so let's first look at the samples. So the first thing to do for every problem is to look over the samples. So first sample is pretty straightforward. There can only be one option, and the one option doesn't require any modifications, right? So we already have like 2 like MMOs, like MMOs here, MOOs. And then they're already in the original array, and we don't have to change anything to keep them. So this problem, it doesn't really change anything. Second case, we see that if we have MO, let's write it down. MOMOOBAA 2 3 and then QQQCQQ. And we need at least 2 occurrences. So we see originally, so basically AQQ, we can turn this A into a Q, and we will get, no, 2 AQQs here, right? So this one and this one by doing a modification. However, we can also do different modifications. We can instead turn this A into a B, and we'll get 2 BAAs, right? So that's another possible one. And the third one is turning, this Q into a C, and we'll have two CQQs. Okay, so that's our three possible explanations. And so first off, like let's see, like our first potential solution, like is let's try turning every single possible character into any other possible character, right? So let's just loop through the entire array, and every single time we do like change any character into like any other character, and then we loop through the array one more time, and then do a quick count over how many occurrences of like ABB there are. Where like ABB are not actual characters; they're just like representations of characters. Okay, so first case, let's first of all we have to think about the time complexity of that. So it's going to be n changes 26 options for every single change, or 25 options, because you can't, like, there's no reason to change it to itself. Actually, yeah, there's no reason to change it to itself. So it's n times 25, but then to query the whole thing, it's another n. It's another n operations, right? Because to query the whole thing, we have to, like, look at this, then look at this, then look at this, then look at this, and basically do all these operations. So in order to do this, oh, wait, I think, did everyone, okay. So in order to do this, so the number of operations here are actually going to be, wait, can everyone stop drawing on the whiteboard? I think we need to, how do we change the settings? Uh, okay, yeah, no, you're good. You're good. Just, yeah. Okay, it's fine. Okay, so basically the time complexity of this is going to be O of 25 n squared. Well, like let's not be big O, because technically big O should just be O of n squared. But like, yeah, so n times 25 times n is going to be equal to 20,000 squared times 25. And we can just tell that this is gonna be way too big. I think this is around, yeah, this is like 10 to the 10th, I think. Yeah, this is 10 to the 10th, which is obviously not going to pass, but this is going to pass the first sample. So first of all, like if you really got stuck in this problem, I think this was a pretty easy solution for this problem, where it's just, yeah, 10 to the 10th. Where it's n, yeah, where it's 25 n squared passes for n less than 100, but this is not going to pass for the main solution. So the main observation we have to make here is that although the number of possible changes we can make is really huge, right? There's n possible changes we can make, and n squared is obviously never going to pass. But the like we have to notice that the total number of combinations of ABB is not that big. Or like, actually, like I'll rename this to C1, I'll use C1, C2, C2. This is not that many combinations. In fact, there's only, so if we choose the first character to be anything, so this is 26. Second character can also only be another character. So C2 has 26 options. It has to be different as well. So it only has 25 options. So total number of options is 26 times 25, which is 650. So there's actually only 650 possible combinations of the possible answers. And now, if we just quickly do the math, we see that 650 times 20,000 is around 12 million-ish, which is going to pass in time. So now let's try to think of a way we can potentially get a n times like just 650 solution. So first off, if we fix the number we want, if we fix like the combination we want, let's say we fix for this problem, we fix it to be AQQ, yeah. So first off, the first step is to loop over and identify every single AQQ we currently have. And obviously, if we already have an AQQ, there's no reason to potentially disrupt it and turn it into another, because there's no reason to lose one AQQ to get another AQQ, right? Because that means that our answer is not changing at all. So we fix these and basically just make these off limits. So this is the first. So we loop over it, and yeah, we want to make sure that we don't modify any of these characters. Because if we modify these characters, if we modify these characters, we're going to not increase our answer at any way. So then the next step is, so after we this initial loop, we mark these characters as off limits, but then every other character can be modified. Then we loop through it again, and for every single three characters, we just see if these three characters can be changed into AQQ. So how you actually do this is just like, you just do a couple if statements, right? So you see like, yeah, like if the first two characters are like, if the first two characters are uncertain, like if the first character matches this one, second character matches this one, then the third character can be changed. Or like, if these two match, then this one can be changed. And like regardless. So you just do like three cases. And if we loop through this, right? So this AAA cannot be changed to AQQ, but if we keep looping through it, this CQQ can be changed to AQQ, right? Because these two match up. The first one's different, but yeah, we can just change one character, change this to A, and AQQ gives the answer. And so if we find that you can change it, then we add one to the answer. So the answer will be 1 plus 1 equals 2. And then we compare this to F to see if AQQ is a potential answer. Um, one mistake, one mistake I myself made on this contest was I thought initially that basically I could take any single, basically I could do this all in one loop, basically seeing that like I thought initially that I could basically loop through the whole thing and like I thought that no modifications would basically change pre-existing modifications. So like for example, here I thought that okay, because this is AQQ, I basically just looped through the whole thing and like tried to change this to AQQ. But that doesn't actually work because yeah, the issue is that a modification to create a new answer, right? So like let's say the target one is still AQQ. This will create a new AQQ here, but in doing so, we got rid of this previous one. So the most important thing to note is that yeah, like doing a modification to create a new target can get rid of an old one. So you have to do a loop to begin with to basically mark all these pre-existing ones as off limits before doing the loop on the whole thing again to check for any modifications that can be made. Okay. Does anyone have any questions about this? I think in general, like the main observation of this problem is the fact that like n is too big, but the total number of possible answers is less than n, right? The total number of possible answers is just 650. So in doing so, we basically can replace one of the n in the time complexity with a 650 in the time complexity. And that's what makes this problem a lot more solvable. Okay. If no one's any questions, I'm going to basically just do more of a contest recap now. Okay. So this contest was kind of unique in that all three of these problems were ad hoc problems. Like you can kind of call the first problem like maybe a math problem, but even then it's not really. Like it's mostly just you have to make the observation that, you can't actually get the yeah, you can't actually loop through all of n and you have to like do some like an observation to instead group the numbers into like broader categories. And yeah, so there's no real like algorithm knowledge or anything needed to this contest. So in some ways it's easier. The code here was pretty short. Like for example, the code, I think problem 2 I heard was the problem that gave most students like issues. But if you like yeah, if you actually have to make the observation, the code ends up being like only a few, I don't know, like only like a few lines pretty much. Like so the code is really easy, but you just have to have the knowledge to like make the observation. So Ethan, the projected cutoff score, honestly, it's really hard to say. Like I haven't spoken to enough students about question 2 about the contest to see like how they did. Like I'm gonna guess it's probably around 750. Like I don't think this was that hard of a contest, but then again, it also might be like because yeah, like if the observations were made, it becomes really easy. But for question 2, right? If the observation wasn't made, it's like yeah, like I think if the observation wasn't made, the problem becomes pretty tricky. But even so, I think like it was pretty easy to get partials on all the problems, right? So the second problem could have been done with the second problem, yeah, the second problem, I think the first two test cases were doable without the observation. It was n less than or equal to 100, q less than or equal to 1000. That one was doable by just brute forcing, simulating the whole cube, and just yeah, and just basically just checking it every single time. So I think the cutoff should be around the 750 range, probably, if I had to guess. But I'm not too sure. But okay, so the main thing to take away from this contest is yeah, just get more practice in, like try to build your knowledge of like seeing more types of problems and just like seeing the like problems building problem solving skills required in order to make these observations. Um and also a second really important part is, being able to code the brute force solutions. So I think for all three of these problems, there was a pretty simple brute force for like half the test cases. So problem one, it was just obviously like all three of these problems were just simulation problems if you didn't have to make the observation. So problem one, you just like loop over, check every single number. Problem two, you just simulate the whole cube and just check every single column every time you make a query. Problem three, you just like loop over the whole string. You try every single modification, and then you like loop over again to check. So like we see here like this really easy brute force simulation solutions for all three of these problems without the observation. And I think that if you solve two problems and just do the brute force for the last problem, you probably will pass the contest because I think that'll give you around like over 800 points, and 800 points, yeah, passes any single contest. So yeah, I think that's the main takeaway from this contest. Just get more used to more ad hoc. I think ad hoc's probably gonna appear more and more on USACO, and also, yeah, just be ready to code the brute force solution to get any points you need. I think that's Richard. Should we go on to the next slide? I think that's pretty much all I have to say.
Okay, yeah, thank you, Alex. Hope all of you learn from the solutions and keep improving your coding skills. I like to say USACO contest is the way for you to learn and improve your coding capabilities. It's the way to show your learning. I think the learning coding goal to pass your cycle is just one of them. If you pass or don't pass, sometimes it doesn't matter. If you know the skills, it will help you grow. At XCamp, some of you already know our achievements in the past almost 8 years. We have 300 more students passed in the silver and above, 60 in the platinum division, 27 joined the USACO finalist. Two of them got European Girls Olympiad Mathematics medalist. One got IOI, International Olympiad of Mathematics good medalist. Last year we have 11 students got MIT offer. This year we just heard the ROI student, he just got the offer from MIT too. Yeah, USACO is a long journey. Hope you enjoy that. At XCamp, we are here to help you and support you. So we have on-site camps. It's coming. For the winter camp, we have December 26th to 30th. It's in South Bay, San Jose. If you are interested, you can join our USACO Bronze Camp. Also in the summer, we have another 2 weeks from late July to August 2. We have year-round weekly classes. We have 4 quarters a year, 10 weeks for each quarter of the class. Also, as we showed last slides, mock test is one important way for you to practice, especially to prepare the USACO contest. Sometimes you learn this knowledge, but you need to practice to how apply them. Also, we have grandmaster classes that's mostly for the USACO gold and platinum level. Also the US Camp and the IOI. Also, we have APCSA series. If you would like to pass APCS or got 5 in APCS, we are here to help you. This kind of journey. If you are interested in USACO journey, XCamp may be one of your good choices. Okay, that's good. Thank you all. Hope you are continue learning coding. Also, for this season, there's 3 more contests coming. If you have any questions, you can reach XM staff faculties. Yeah, thank you.